Good Friday evening, everyone, and welcome back to this channel. Hope you guys have had a good Friday so far and continue to have a good Friday as we make our way through the evening hours. It is now 7:54 p.m. Eastern Time as of the time I'm speaking, and I'm making this video just to kind of go over the latest and greatest when it comes to this specific storm system this weekend. At the end of this video, we will look at some model runs for the longer range, but I really went into the longer range discussion in this morning's video and want to keep this video shorter. So for that reason, this is really just going to be focused on this event. But yeah, we're going to go over some satellite radar, different analysis stuff for those of you who are interested and under the gun for this severe weather. So stay tuned for that in this video. Thank you guys for tuning in as always, and like this video if you like it. Subscribe if you've not done so already, and please leave a comment down below where you're watching from. It'd be greatly appreciated. So we're actually going to start this off just a bit differently than we typically do. We're looking at the radar here. We can go site by site here. So this is down at the Lubbock site in Texas, and you can see we do have some more locally intense convection going on just west of the area right now as we're speaking. I have surface observations overlaid here, and you can see how these flags are kind of pointing down to the south. That means we have southerly wind kind of getting going across this area. We'll look at mesoscale analysis here in just a second that will kind of help us determine where these features are in the low levels of the atmosphere, the mid levels, even the upper levels. But right now we do have some sort of surface low developing because you can follow these. I need to pick a different color. We can follow these, and they kind of go up like this, right? And then these kind of come in like this. So somewhere in here, there's a very weak and broad surface low starting to form. It's called cyclogenesis. There's nothing really on the radar to speak of at this moment. We were talking about this in this morning's video. We might not really see more storms forming for another couple of hours. And this blue here, it says probability of a watch issuance 20%. This is a mesoscale discussion from the experts themselves. And the summary reads, a marginal threat for severe gust and hail may develop across parts of West Texas this evening. The threat is expected to be too isolated for watch issuance. And so what they're really saying is in the far southern areas, really kind of down in here. Actually, hold on. I should be able to turn on the day one out. Yeah, I don't know why that wasn't on. So we can see the outlook here. And they're really talking about for the far southern areas, the probability of a watch being issued in the next couple hours is pretty low because this stuff should be so isolated. So if you were attentive just a matter of seconds ago, you may have seen this. This was a warning that was issued. Well, we have to pick a different site. There was a hail pour in one of these storms that was rolling through areas, just far eastern and southeastern areas of Kansas, just a matter of 10 minutes ago or so, but it has since died off. So there is convection up here that could pack a punch every now and then. But down here in this area, this is what we see right now. There is some hail in this. I mean, we can go through products here. Nothing about this screams severe yet, but we could start to see this increase with time. So we're going to switch this back to the web here. We're going to be using a few different tools here. So this is satellite. And what I'm showing you is water vapor imagery. I'm not showing you that typical true color imagery because the sun's gone down. It's not very helpful anymore for determining where stuff is. You'll see these little plus signs. These are lightning. And they're different types of lightning and different ages, all of that stuff. But you can see how if I play this loop right about here, you start to see these little plus signs, those little lightning signals come up from the geostationary lightning mapper network that we have. And it really starts to increase over the last little bit of time. You can see on this, what am I trying to say? This water vapor imagery, there is an area here where these colors are darker. That means these storms are kind of spiking up into the atmosphere. They're getting taller. So we're seeing the beginnings of this already now. I can switch products here. We can look at infrared imagery, and you can see that this is cloud top temperature. So the brighter this red is, it even goes there. I don't have the color scale turned on, but this color even goes to like black color. It gets so dark. And that is for the really, really tall thunderstorms, but you can see this locally higher area. So I would expect that this is going to begin intensifying, and that is really the only couple of products that we have to show you. You can kind of see those anvils there. Now, I can overlay the jet stream, and you can see that we do have flow across this area that is supportive of severe weather. So we go up here to the SPC Outlook, and this is today's. When was this issued? This actually, let me see if there's an update. Yeah, this is the latest one we have. Another one will drop relatively soon. I don't think they're going to change it much, but this is just that outlook we were seeing in the beginning. You can see this marginal risk area through areas of Texas, up in Oklahoma, even far southern areas of Kansas. And if you break this down by type, no tornado threat, according to the Storm Prediction Center. That is not to say that they can't happen, but typically they are pretty accurate in what they say in that sense. 5% chance of winds exceeding 50 knots or greater, so 55 miles an hour, 60 miles an hour or so, and then the hail threat is obviously the full size there. So we can look, and we will, at the next day. This is upgraded. Not in the area I thought it would initially, but it has upgraded. This is tomorrow for Saturday. Uh, this kind of severe chart, this index here we can look at. And so yeah, you see this marginal risk is level 1 out of 5, and a pretty large area here. It goes all the way from the San Angelo area of Texas all the way back to the Mississippi-Alabama border and up along the Red River. And obviously, the thing that will draw your eyes is this slight risk, this yellow here that you see in areas of Louisiana and the far southwestern areas of Mississippi, and then a good chunk of eastern Texas. And if you break this down by type, you can see how the tornado threat is actually they've upped this to a 5%. So they've trended that up. The wind is also trended up to a 15% chance, and the hail has remained. So this, I think, what this is really telling me is that when these storms get going, they'll have a potential for hail, but as they strengthen, as they move east, they'll transition to more of a line, and you'll see them start to produce more wind related phenomena as opposed to just hail. So we can also look at mesoscale analysis. So I'm going to take this here. So this is the jet stream as well. This is another way of looking at it. I'm going to turn off the radar so it kind of gets a little bit bolder here. You can see how, just kind of like we were talking about with this morning's models, there's kind of a nose of higher winds inching their way into areas of Texas, right where these storms are starting to fire here. And if you look here, that's leading to a lot of shear. I mean, a lot of shear. Areas where these storms are right now, you can turn it back on, you can see the radar pops up. There's upwards of 80 knots of shear in this area. So extreme amounts, I would say, of shear throughout the atmosphere here. So I honestly wonder if this will almost mitigate severe potential because there's so much shear in this area, it could kind of shred storms apart before they get going. So that's something to keep in mind. You look down at thermodynamics, there's a lot. You can see the shaded blue color is called mixed layer CIN, convective inhibition. You can see it MLCIN, convective inhibition. And that is just essentially negative CAPE. It's the cap the atmosphere has on it that storms have to overcome before they can explode. So there's some to work with here, and you can see in these red contours here, that is where the ML CAPE is, the convective available potential energies, that instability, that fuel the storms have. Not a lot. We have this 500 joules per kilogram contour here making its way up near where these storms are, and based on the RAP, if we go like 2 more hours out, you can see how it models a few different things. You can see the radar model underneath it, and it's got the ML CIN, it's got the ML CAPE, and you can see how there's that tongue of 500 joules per kilogram that makes it up further north. So go even further, it doesn't really grow a whole lot necessarily. So very, very marginal CAPE values. I think that's ultimately what is going to kind of mitigate the severe potential in this area. We can look down here, not here. We can look here at the low-level jet and see what it is showing us. Is there no shading? Yeah, so there's not, the low-level jet is not doing a whole lot as of right now. You can see how it's oriented out of the south across almost all of the area, so that is bringing that Gulf moisture up. And if we take this out a few more, you can see how it starts to strengthen a little bit. So there will be an axis where the low level jet increases to as much as 30, maybe 40 knots. So we'll have to watch for that. But as of right now, pretty calm. It's pretty typical that the low level jet increases as the sun goes down due to the planetary boundary layer, the atmospheric boundary layer changing. So we will see this. This is less than a mile above your head right now. So if you live in these areas, it's not that far up that this is happening. What else are we going to look at? This is right now, this is kind of a way to summarize all of that. It's the supercell composite parameter. Not the best thing to look at, but it is something. It can just kind of show you where ingredients are lining up the most. And you can see uh, two. It's an index. It goes from 0 all the way up to like, a pretty high number. In fact, I don't even think it has a cap on it. But when you get into those 4s to 6s, you start to see more severe weather. Do we get those? Not really, which is something to think of. Although at the end, at the 6 hour forecast time, we do see 4 starting to show up in southern areas of Texas. So this is, again, not the best thing to look at. There's other things that you can look at, and there's other things you should look at. But if you kind of break down the individual ingredients, you will see that not a lot is lining up right now. This is our temperature and dew point, and you can see the shaded, this green, that's where our dew points are. And so we barely have 60s inland, dew point wise. So not a whole lot of moisture to work with here. So we can look at that a slightly different way here by looking at the surface map. So this is literally the raw information coming in from all of the surface observations, kind of like what you saw in the beginning of this video, how you've got all of these little like stations here, and they all report temperature, dew point, pressure, wind speed, and direction. So you can see these winds kind of come up like this, they kind of go over, and then there's wind kind of coming up like this. So somewhere in this area, we have a surface low forming, somewhere, but it's very, very broad. And you can see if you look at the bottom number, see how this one, for example, says 75 over 56. The 56 is the dew point. You want 60s, really. So if you look back in across this area here, we have 50s, low 50s. And at the stations like this one, for example, where there's like two little tiny dots beside it, might be hard for you guys to see. That means it's raining there. So again, not a whole lot of moisture to work with. I think that will be some sort of kind of capping mechanism we have. So we're going to look at observed soundings from a few different locations. This is the Midland, Odessa area. Now, if we go back, this is the radar. So this is pretty close. It's pretty close. And yeah, so that sounding there, it could be down here, somewhere in between where it says Lubbock and Midland, right in this area. So it's a little bit south of where our storms are right now, but regardless, it's close. And if you analyze this, it kind of shows exactly what we've just been seeing. I talked about this in this morning's video, what these things are. This red line here is the temperature line, the actual measured temperature by a weather balloon. This was as of 6 p.m. Central Time, so just about an hour ago. And you can see how it cools off and then it kind of warms back up. Where it warms up, that's where the tropopause is, where it starts to change to the stratosphere, all that stuff. But you can also see this green is the dew point line, and you see how they're pretty close to each other a lot of the way up through the atmosphere. Because as you go up this chart here, you're also going up in the atmosphere. So there's a pretty solid layer where they're close. That means it's very cloudy. Just think about it like that. And the spreads between these, so it's a 74 over 54. That's exactly 20 degrees apart. That is not favorable for severe weather, especially in an environment like this where you need as much instability as possible. Instability being said, though, this dotted line that kind of goes like this, that I just covered up, that is the parcel temperature. So you see how it is to the right? It's over here in comparison to the temperature line. That means there is instability here because your preschool science class would tell you that warm air likes to rise. So if you look down here at the measurements, mixed layer Cape, see how there's other values. Look at the mixed layer. That is the most reasonable estimation of instability. We have 650 joules per kilogram. That's not great, but I would argue that it is enough. And if you look over here at the hodograph, the wind part of this, you can see how I mean, our right, so our storm motion is like this. So if you're standing here, you can draw a vector, and your storms are going that way. And we just saw that. But this curvature, like this, it kind of mimics what shape the storms would be, if that makes any sense at all. So the fact that this has a hook on the end means that the storms themselves could be kind of this kidney bean shape. So something to keep in mind. The hodograph will start to enlarge as you see where that says 1 right there. That is 1 kilometer. That's about where the low level jet is. With time, as we were just seeing, this will strengthen. So it'll go to maybe 30 knots, maybe 40. So if you were to draw it in again, let's make this a little smaller, your hodograph would go up like this and then back down. That is a lot more low level curvature. And that would mean that there's more tornado potential. But you notice how the Storm Prediction Center wasn't even really calling for tornadoes. So it's a very conditional threat. So we go from there and we look at some of the actual model runs that we have to look at here. I'm going to full screen this so it's just a little bit bigger. So we're starting off with the HRRR, which I think is the king of all short range model guidance. And let's back this up a few here. Actually, let's reload it first. So this is valid right about now. So it's picking up pretty well on some thunderstorms in these areas. You will notice how not a whole lot happens with them. They kind of roll their way up to the northeast and don't really intensify or weaken. They just kind of roll around. This could be heavy rain, maybe some lightning. We're already seeing lightning with these, as we talked about a second ago. But it really isn't. You get into closer to tomorrow morning, then you have something happening. I'll give you a little bit of information about the Storm Prediction Center outlooks. See where it says right here, 10Z. That is Zulu time. So all that you need to know is that the Storm Prediction Center outlooks run from the time they were issued. So, for example, the last one was 20 UTC, 20Z. And they run from that time to 12Z the next morning. So, for example, if I take this 2 more, that outlook, that kind of long oval-shaped marginal risk is valid through this frame right here. So we have another 12 hours or so that it is valid. And that's why I think this actually could be kind of a late bloomer thing where we have an intense line cluster of storms that gets going here. Like this would be like 4 or 5 a.m. So anyway, after that, this continues on. Some sort of line of storms moves, kind of parallels the Red River, and this must be the last. Yeah, it is. So the 0Z, this will be a big run, is running right now. So I'll take you out to the end of it here. So this is the last frame. This is valid at 16Z. This would be about 10 a.m. tomorrow morning, and we have this line of storms, cluster of storms ongoing south of the Red River. I'm going to have to change model runs here to be able to show you the rest. So we'll start off here and move out a little bit. So this is about lunchtime, about noon to 1 a.m. and we have, or 1 p.m., sorry, and we have this kind of line of storms. Now you'll notice how it expands to the south a bit as we make our way through the afternoon hours tomorrow. And I do think, notice where that slight risk was issued, down here. We start to see these storms really intensify on our model guidance. I think it's doing a good job here. Just indicating these could just be more intense storms, just to put it simply. And you see how it kind of bows out in the middle, like it's not just a perfectly straight line, it kind of arches out. That indicates more damaging wind potential. I don't think we're about to see a derecho tomorrow where we get these swaths of 100-mile-per-hour wind gusts or anything crazy like that. But I do think it's very possible we see something uh, pretty intense in some of these areas. Now I'm going to go back one frame. I'm going to pull a sounding. So this is similar to what we just looked at that was observed. So right off the bat, what draws my eye is how curved that low-level hodograph is. So this would support like embedded supercells and embedded tornado potential in this line. Just to put it simply. Um, and you see where this kind of blue writing is? It's hard for you guys to read. That is the upwind propagation vector. Actually, yeah, that's that. Um, I apologize for showing you that. I meant to show you this one. See, it says DN. That says downwind. That's what that means, propagation vector. So when storms start to form into a line and they start to move along with the wind, the flow in the atmosphere, this is the vector that you would draw from yourself standing at not moving. That is the vector you would draw. So notice how it really speeds up. This is out here near 90 knots of forward speed. So it shows how this line, if it forms and really gets its act together, it could really accelerate forward speed, which would overall increase your damaging wind potential. Uh, but you see it down here, and it kind of just moves due east through areas of Louisiana, hits the Mississippi River, and remains kind of that bow shape, and we'll stop it here. What about the RRFSA model? Well, started off here, and again, I mean, this is valid right about now, kind of doing pretty well. Cluster storms, and then does it do anything with that second? It does. Kind of another cluster of storms just before the sun comes up tomorrow morning. So a couple rounds of storms in areas of west central Texas, and then it starts to get its act together a bit more. But as we make our way into the afternoon, really gets its act together. And then from I don't know, the kind of the architects here point south, you have this line slash cluster of storms, and it does something kind of similar. There's areas where it bows out more, hits the Mississippi River, and then rolls its way to the east. So we pick back up where we left off. This is midnight, tomorrow night into Sunday morning, and we have this line of storm. So where does it go? Update this, unfortunately. So we move this on. You can see how this low pressure literally looks like a comma here. It's fully wrapping in moisture as it's strengthening, and you can see there's just a whole lot of moisture. I think our severe potential is limited in a lot of these areas just because the thermodynamics just don't seem to line up very well. But there's a lot of rain moving through areas of, I mean, northern Alabama, northern Georgia, South Carolina, North Carolina. I mean, a lot of these areas just receiving just straight rain that's falling in kind of marginal temperatures. And then you do see these lines down here that could indicate stronger storms. And the RRFSA model, I'm going to see if it lets me. It does. So we move this on. This is getting into Sunday morning. Everything kind of breaks apart a little bit, but you see these clusters down here. This is a little bit more intense, but very much possible to see this, I think. And, a lot of rain for a lot of the same areas. This even likes the idea of getting some stronger storms into like the Midlands of South Carolina, for example. So something to watch there. It moves offshore, but this line moving down here through areas of Florida towards Tampa Bay could also pack a punch. So there's that. Now, if we look at the accumulated wind gusts based on the latest run of the HRRR that went long enough, I'm going to see here. I only have 21 hours of it. It's unfortunate. So switch this back, let it load in. But yeah, this is the last full run, and you can see how there's these kind of lines here, these kind of bars that go like this. That is the line every time it's measured, and it kind of assumes things. But there are strong wind gusts. You can see down here, right in the area they've issued that slight risk. So I think it's showing up pretty well here. We could have gusts upwards of maybe 60 miles an hour. Well, there's a 60-mile-per-hour wind gust modeled right there. So you can see it pretty obviously here, just kind of highlighted. So we also look at the HRRR for when it comes to moisture, and I think this is interesting. This does not go the entire way through this event yet, but you can see areas of Arkansas and kind of northeast Texas, a lot of Oklahoma, Missouri. I mean, there's as much as like 4.5 inches that fall just south of Little Rock based on this. So quite a bit of precipitation is on the way. And then areas further to the east here, it's not done raining at this point. This is only early afternoon on Sunday. So you've got a while to go. But up near half an inch or over, even as much as an inch in northern Georgia, even by Sunday afternoon, we still going. So a lot of rain to come in general. So we also, just because I will show you, this is the latest full run. I'm going to update this. Yes, latest full run of the Euro, just kind of to get past this. So we're gonna have to do. I don't know what just happened. We're gonna have to switch this back. We're gonna get past this system, right? And then we get out towards the this coming Wednesday. So this is some longer range discussion here. And you see some sort of kind of sprawled out low pressure in the northern plains. I think this could bring a decent snowstorm to areas of the far northern plains and upper Midwest, maybe parts of the uh, Great Lakes region. And nothing crazy about it yet. It could change. There looks to be some sort of storm system that rolls through areas of the east, just the eastern U.S. in general, between the say the 20th and the 23rd, 22nd. So there's another one. We have another low pressure kind of rolling through the northern plains again on the 26th. Not a forecast though, and then a whole lot of rain. This would be a severe event, almost undoubtedly. In fact, just for giggles, I'm going to show you what the temperatures are. And yeah, we got temperatures in the 60s, maybe 70s. So it's kind of a moderate severe event. And you continue that on, forms into a line, moves east, and this is the last frame. So all of that to say, I just mentioned like 4 different storm systems. And I said for each one of them, could be this, could be that, maybe, I don't know. So a lot of unknowns exist. This pattern is kind of difficult to figure out, but I do absolutely think that we have potential for an active pattern through the rest of pretty much the rest of the month here. And really, if I had to circle anywhere, I'd circle this region and obviously areas of the West. So I don't ever do this. I'm gonna take this back right about here, and then I'm gonna switch it to the where are you guys at? The Western U.S. sector here. I'm just gonna take a closer look because I've mentioned before that I think you guys are in for a more active pattern. But we get into the 17th, the 18th. It's just a lot of snow, just a lot of energy rolling through areas of the western U.S. and just kind of repeat storms. There's another little active period, a bunch of snow. And I think that this could include valley snow. You know, we often say that higher elevated regions are the areas that get snow. That's obvious. Most people know that. But even the valleys, the kind of areas that aren't as likely to get snow, I think have the potential to do so with a pattern like this. You can just I put this in motion. You see a lot going on. Nothing too specific. It's very hard to forecast for this area because everything is elevation and microclimate driven. So it's very hard to for someone like me to forecast. So that's why I would recommend that you just kind of pay pay attention, stay tuned to your local people. They know your area better than I would. But just it does look like we have multiple shots for winter weather across the western U.S. So that being said, let's see where we are here. I'm going to update this and get rid of the jet stream here. So, I mean, these storms, I'm going to do this now. I'm going to check back in on the radar because they do appear to be intensifying. Yeah, so there's some sort of uh, storm cluster, if you will, about to hit downtown Lubbock. Let's see, put this in motion. Yeah, so I mean, there's something to it. Velocity wise, that's interesting. So we have some sort of convergence signature here. These reds would indicate that the hydrometeors, the raindrops that are being picked up by the radar, are moving away. Green indicates that they are coming towards. So you see in this area where they meet here, you take that and turn on the precipitation. It's right in the middle of it. So could indicate that there's some sort of very strong updraft at the surface here. Interesting feature. Also could indicate the start of some rotation. We look at a few other products here. So nothing crazy about this by any means. I'm going to click on another site. So what this product does here is estimate the height in the atmosphere of these cloud tops. So that says 49,000 feet. So these storms are definitely intensifying. They're growing taller, which almost always when it comes to storms means that they are intensifying. So this will be a little cell to watch. Areas down here further to the south, like this little thing um, north of Frankel City, Texas. Never even heard of that, but could kind of turn into something a little bit more. And there is convection up in areas of far northern Oklahoma, southern areas of Kansas that could pack a punch, but nothing crazy is expected as of now. So that being said, thank you guys for watching. Hopefully that we'll have something to kind of watch tomorrow. I'm a big severe weather fan. You guys probably know that by now, hence the entire video about it. So I hope you guys enjoyed it. Thanks for watching. I'll get a video out to you guys tomorrow, probably in the morning, just kind of go over all of the latest information. And with that, I will see you in the next one. Thank you for watching.